The Parkinson's Podcast is brought to you by the Davis Phinney Foundation and brings you the stories, wisdom, and expertise of people living with Parkinson's, care partners, and Parkinson's professionals. In the first episode of this three-part series, Connie Carpenter Phinney, care partner for over 25 years to her husband Davis, and Dr. Mark Mapstone, a neuropsychologist at UC Irvine, discuss how brain chemistry impacts thinking, memory, emotions, and more for people with Parkinson's. If you find our podcast and other resources helpful, please consider donating to support our work by visiting dpf.org/donate. That's dpf.org/donate.
Hey everybody, welcome. We have a special guest on the Parkinson's Podcast, a good friend of the Davis Phinney Foundation and a frequent guest on our Care Partner Meetup. Dr. Mark Mapstone is coming to us from UC Irvine, where he is a professor of neurology. He is a neuropsychologist, and your voice is an important one for those of us in the care partner side, as well as for people with Parkinson's. And so I know we're going to learn a lot today about neuropsychology. Let's dive into it. But first, tell me a little bit about your background. What led you to become a neuropsychologist?
So I've been in neuropsychology for going on 27 years now, just over 27 years. What drew me was really just the fascination. I'm fascinated by people. I just really love people. And it's mostly, the people in my life that I was exposed to and that I interacted with when I was growing up as a kid, and then through college, and then through graduate school and beyond. I just really like interacting with people and getting to know what makes them tick. And fundamentally, you're talking about the brain and who people are. So I think I just ended up in this space because I wanted to help people. And I'm just fascinated by people and how we're all very, very different, and how our life paths produce different individuals and different experiences, and how that makes us who we are. And so I really wanted to learn more about that. Neuropsychology is essentially that, and the neuroscience of cognition is what I focus on. So I guess the best way to describe how I ended up here.
Yeah, the neuroscience of cognition. And how did you decide to go that way versus psychology?
Well, they're really very much intertwined. And so neuropsychology is a subfield of psychology. Psychology is a study of the mind, broadly writ. Neuropsychology is a subspecialty of psychology in which we're interested in how the organic structure of the brain is a physical thing. The central nervous system is something you can touch and feel, and we can understand how it works. And those physical properties produce the emergent property of behavior and cognition. So these things that happen that are so hard to describe are really the output of physical processes. And that's where neuropsychology lives, is it's trying to understand how the physical instantiation of the brain produces behavior and thought and cognition and emotion and planning, and everything that we do that makes us uniquely human emerges out of the physical properties of brain and tissue. And so neuropsychology is right on that border of how does the brain produce all of these things that make us who we are.
Yeah, and I feel like when we talk about Parkinson's, we're always talking about a specific, geographic landmark in the brain, right? The substantia nigra and the subthalamic nucleus and different areas that most of us with, the layperson doesn't really know where or why we're talking about structures within the brain, but that is a big part of what you're studying, right? And also what those areas do in an undiseased state and in a disease state, and how that affects us. So I really want to dive into a little bit at the landscape of the brain and talk about dopamine and what it is and what happens when you're missing it.
Yeah, well, that's a big topic. Certainly, I can give you some broad brush approaches to that. So there is a geography to the brain. The brain is not just one big mass of stuff up there. There are distinct little pieces that work together to produce these different behaviors that we're interested in. When I say behaviors, these are thoughts, emotions. These are things like planning, feelings that we have, but there are also some very basic things like feeling hungry, moving, being able to interact with our environments. All these things are produced and orchestrated by these individual components within the brain. And the different pieces of the brain tend to talk to each other in large scale networks across the brain. And there are many, many different kinds of networks, and they all support different kinds of functions. Sometimes they overlap at certain areas. So there are very critical regions of the brain that overlap for various different kinds of functions. And this is where you mentioned a couple of very specific nuclei called the substantia nigra, the subthalamic nucleus, the globus pallidus. These are aspects of the brain where many of these overlapping brain networks kind of come together in one place. And this is one of the reasons why a disease like Parkinson's disease can have so many different phenotypes, or it can look very differently across different people. There are some similarities because the same sorts of the brain are being affected, but there are also diversity because that part of the brain can be important for different kinds of functions. So this is where there's like overlapping Venn diagrams, and that intersection is where, for example, the substantia nigra lives.
When you talk about phenotypes, that means how it plays out in a person with Parkinson's, or?
Yeah, I'm sorry, how it looks. A phenotype is how it looks. So one person with Parkinson's might have a tremor predominant, and someone else has more cognitive problems or emotional problems. But each person might have a little bit of the three. We tend to think of Parkinson's disease as being a movement disorder primarily, because that's the thing that we can see the most readily. But it also has components of emotion or mood, and also cognition. And so those three networks, movement, emotion, and thinking or cognition, overlap at some of these areas of the brain, like the substantia nigra.
Yeah, no, and it's fascinating. I think that so often we talk about motor and non-motor symptoms, but we don't break it into those three. Well, they're overlapping, but distinct areas, right? Emotion, cognition, and movement. Most people associate movement, the tremor. Maybe they've seen Michael J. Fox on TV who exhibits a lot of symptoms. But what we don't see, and what our friends and family don't see, and even I as a care partner now of 25 years see and know, but don't really experience, is the cognition, and how it plays out. I do experience the emotion more, I think, because that's more outward facing, whereas cognition is much more complicated in a person with Parkinson's. And that's a lot of what we want to talk about here, is how they overlap, cognition and emotion. When a person with Parkinson's is diagnosed and they start to look into this, the big word that jumps out is dopamine.
Right.
And it's used a lot now in the popular culture because people talk about, dopamine bumps, that they get from social media. How do we process and understand dopamine for the person with Parkinson's and separate it from some of those other conversations we hear about, a bump in dopamine?
So dopamine is a critical neurochemical that we all have and is in our brains. And it drives or helps support reward-related behaviors. And so when we do things, sometimes we can feel reward from that behavior. And those things that are reinforcing, dopamine helps us to reinforce a particular behavior that's adaptive. So when you eat something that's going to make you feel full and it's something that's enjoyable, you're going to get a little bit of a dopamine hit, for example, because your system wants to encourage you to continue to do that. And you will respond as an organism to those little bumps of dopamine. Turns out there's a lot of things that can release dopamine, and social media is one of them. For example, there are some pathological or not so good behaviors like gambling or things like this that can result in bumps of dopamine that can lead to problems. So there are a lot of different ways that we can modulate the dopamine system in our brain to allow us to continue to do behaviors that are reinforced by this system. Dopamine is a really critical neurochemical that modulates our behaviors. Most often for the good, but sometimes for the not so good. So we can end up doing things that are rewarded by our systems that are not good for us. For example, the consequences of compulsive gambling, for example. It turns out that the area of the brain that's responsible for producing that chemical dopamine is the substantia nigra. And there are certain neurons or brain cells in the substantia nigra that produce dopamine. So far, a not well understood mechanism, those cells die off in this disease we call Parkinson's disease. And this was a disease that was described by a doctor named Parkinson, and so is named after him. And these cells die off, and we're not exactly sure why. We don't really know yet how to save them, although there are a lot of exciting things in the future that I think are going to be coming down the pike. But these cells die off, and so they produce less dopamine. And dopamine is responsible for reinforcing these networks that we've been talking about. Because the cells die, the functions associated with those networks start to become impaired. And those are largely movement, emotional regulation, and cognition. And so there are networks in the brain that do those things that rely on that chemical dopamine. And when those cells die, they don't produce the behaviors that are associated with those networks.
Right. And, it doesn't actually make sense from a layperson perspective to look at that and say, wait, why does dopamine affect emotion and motor and
Yeah.
cognition? I mean, it's such an important neurochemical in our body. How do we even function without it?
Exactly. And so when you lose those cells that produce dopamine, you get these resultant deficits in those behaviors. Now, I'm kind of painting a very simple picture here with regard to dopamine. It doesn't act alone. There are many, many other neurotransmitters in the brain that do different sorts of things and similar sorts of things and act in conjunction with dopamine. So there are other things going on, but I'm kind of painting a fairly simple picture here that dopamine is driving, but it's not doing it alone.
That is the kind of the essence of what we come to understand at the outset. And then as we live with the disease longer, it becomes even more complicated because the brain itself is complicated and it relies on these feedback loops, right? And so when you miss the dopamine, it's working overtime to try to make up for that, as I understand it. And this is where so many of the symptoms arise. So in the middle of all that, as you're living with Parkinson's, and there are medications you can take that will help you with this, right? Everybody knows that who has Parkinson's, that they can take dopaminergic medications. But it doesn't replace what's lost easily, right? And not without consequence, which is part of the challenge. It does add to the complexity of the conversation, I think.
It's a very, very complex. I mean, the brain is probably the most complex thing that we can understand or don't quite understand, that we are attempting to understand. There are things moving in real time all the time in a multitude of things that we don't comprehend yet. And I think it's really important to remember that the brain is not a static thing. It's not just sitting there. It's always moving. It's always doing something. And at the cellular level, at the chemical level, at the behavioral level, we're always monitoring our environment and everything that's going on both externally and internally, things that are happening within us that we're not even aware of. The brain is monitoring all of these things. So it's a very dynamic organ. So that complicates it by a million times to try to understand how a single, for example, neurotransmitter depletion affects the overall output of the brain. It's just a really, really challenging task.
I think most of our listeners would be interested in how this plays in emotion and cognition for a person with Parkinson's, and then also to understand how cognition can erode over time. We want to talk a little bit about that too.
So I think one of the things that might help to start a conversation like this is to define what we talk about when we're talking about cognition. What is cognition? It's a word that's used to define the multiple things that we do that involve many, many different aspects of our behavior. And it's usually around goal-oriented behavior, the things that we as a person or an individual set up either explicitly or implicitly as our goals or for behavior. They're very context dependent. It depends. My behavior is going to be very different when I'm sitting around the family dinner table than when I'm sitting around, with a bunch of friends at a baseball game. The behavior depends upon your environment and how you interact with your environment and what your goals are within that environmental situation. So cognition is all the different ways that we interact with our environment in order to do the things that we as an organism want to do, as a person want to do. So if my goal in a particular context is to be generative to my family, to help my children understand certain concepts around the dinner table, and it would take a very, very different set of cognitive skills to address that particular goal and make that happen than I would if I were in some other environmental context. So when we think about cognition, we think about some major domains of cognition. There are many, many, many of them, but we can broadly break them down into things like attention and processing speed. That is your ability to kind of register what's going on in your environment, both externally and internally. That's paying attention to things. Everybody knows what that means, but it's really hard to define exactly what attention really is. And then there's also things like executive function, which are decision-making, planning, understanding the consequences of one's behavior, or not understanding what the consequences are. Impulse control. We all have impulses. They guide our behavior, but there are times when you do certain things and there's times that you should not do certain things. So we have to understand those contexts. That's executive control. Think of it like a CEO of a company that's making the big decisions. She wants to do the right thing for the company, and she has to have her behavior guided by this executive function. So attention and processing speed is kind of this base level. Executive's a little higher. It's the higher order thought. Then you also have it supported by things like language. We use language as humans to communicate our ideas and express our ideas and to understand others' emotions and ideas. So this language is a big piece of how we use cognition. There's memory. Obviously, memory is a big one. And this is how we benefit from experience. We learn and we use previous knowledge to guide future behavior. And so memory is an important piece of cognition. And then finally, there's visual spatial abilities, or your ability to operate in your physical environment, understanding where you parked your car in the parking lot. That's a sort of a visual perceptual. It's also kind of memory as well. So these are not isolated functions. They operate together to create all the diversity of complex behavior that we have. And then we have things like social behaviors, the ability to interact with other humans and other animals on this planet. There's motor behaviors, the way that we move and coordinate our muscles so that we can do things that we want to do. Embedded within all of that is personality and individual aspects of who we are and how our history shapes our behaviors. So cognition in general is that big, big umbrella term for which all of these individual little pieces fit. And we can sort of tease those out individually in a cognitive assessment. And that's what a neuropsychologist does. That's what I do when I'm seeing patients clinically. To jump back to something that we started with, and maybe I didn't clearly finish my thought, was what's the difference between cognition and emotion. So cognition, I went over a little bit. I think that the piece about emotion, it's a different set of abilities within an individual that's not actually the mechanism by which we do it. For example, remembering something or making a plan. It's often a motivator for behavior, and it's a way for us to experience our world and put salience on those experiences. We can have a very positive emotion or positive association between a particular context or environmental context. If we go into a place that brings back emotional memories, for example, that are positive, that can guide our behavior in a very different way than if we have a negative memory of a particular context. And we can think of ways where positive memories can reinforce behaviors. You get that little dopamine bump and you want to have that happen again. And then there are times when we don't really want to remember because things are not as happy or emotionally reinforcing. We can think of an extreme example like PTSD, where this is a memory for something that we don't particularly want to remember. And we can't let go. It's something we want to forget. It's an example of when forgetting goes wrong and you actually hold on to a memory that you don't want to. Think of emotions as being things that drive the salience or the importance, and they can be positive, they can be negative, they can be in between, they can be all kinds of different ways. Whereas cognition is more about the actual tools that you use, the memory, the language, the way that you communicate, the visual spatial abilities of how you operate in your environment. So those can be dissociated from each other, but they obviously clearly interact together to drive complex behaviors in the way that we interact.
That's super helpful because I think because we're talking about Parkinson's being a triad, and looking at emotion as well as cognition and the motor symptoms, that it's important to try to tease those apart and sort of understand where they play and how to define them. And the next question was really looking at cognition. I know it's not a brief answer, but looking at what that is and then what to expect with Parkinson's in terms of cognition.
Yeah, I think to get there, we needed to know that things change with age. Cognition changes with age. And we know this. It's a little easier to see something that doesn't seem right or normal than it is to say, well, what is normal? And so I think one of the big questions we have right now in aging and cognition is defining what normal is. That's always changing. Depends on your specific age, but it's a wide range because there's individual variation. So when we say, well, what are the typical things that we see in people with Parkinson's disease, you've kind of got to start with that. Well, what's typical for anybody to begin with? There are some general principles that we do know change with age. And the biggest one that we see is processing speed. As you get older, your neurons, the cells in your brain, simply do not pass along information to each other as quickly and as accurately as they did when you were 15 or 20 years old. They just don't do that. There's lots of reasons, but it's primarily a function of biology and what time does to physical structures on our planet. They change, they degrade over time. If you have something that's older, it probably doesn't work as well as it did when it was newer. And that's essentially what's going on in your brain. The information that's getting passed from one neuron to the next just doesn't get there as quickly as it could, and it doesn't get there often as accurately as it could when you were younger.
Let's stop right there. Let's just accept that and really lean into it because, I'm 68 years old, and I know I'm a lot slower doing most things, athletically and cognitively, right? And I have to think a little bit harder. And so that's such an important point that you're making, that let's try to understand what normal aging and cognition looks like. And now let's talk a little bit then about a person with Parkinson's and why it feels maybe abnormal and why it is abnormal.
Well, it is because the biology is affected more severely in a person with Parkinson's disease. Now, not broadly in that every single neuron and every single cell in the brain is not working the way that it should, worse than a person that's the same age, but rather specific neurons. And we already talked about the substantia nigra and the role of the dopaminergic system and the role of dopamine in particular. Dopamine helps us to pass information along between certain neurons to other certain neurons or certain cells to other cells. Dopamine is one of those chemicals that we need in order to pass along information within certain circuits within the brain that controls certain behaviors. And when that neurochemical is depleted or goes away because the cells that make it are dying, then those neurons don't talk to each other as well. It's fairly specific, so that's why people with Parkinson's disease don't have broad global cognitive changes. They have pretty specific cognitive changes. People with Parkinson's disease, their cognition looks very different from a person with Alzheimer's disease, for example, because the brain networks that are being affected are different brain networks. It's not all the same. It's not one big mass of tissue up there. They're individual bits doing their own part. And the person with Parkinson's disease has a certain area affected that's supported by this dopamine, and the information flowing within that circuit is not getting through. It's very different from the circuit that's involved in Alzheimer's disease or any of the other neurodegenerative diseases that we can talk about. So that's why the person with Parkinson's disease is going to experience things that are different from normal aging, because it's a highly specific network that's being affected.
Thank you for listening to this episode of the Parkinson's Podcast. We hope this conversation helped lay the foundation for understanding how the brain changes in Parkinson's and how those changes show up in everyday experiences. If you find our podcast and other resources helpful, please consider donating to support our work by visiting dpf.org/donate. That's dpf.org/donate. This content includes information, insights, and opinions from our Parkinson's community. The views expressed are those of individual participants and do not constitute medical advice. This content is not intended to substitute for the guidance, advice, or recommendations of your personal healthcare providers.